Today we're going to talk about rational operations, and we're going to start with very simple ones. So the first thing we got to think about, if we look at this example here, and we're going to call this example A, we have x squared minus 25 over x squared minus 3x minus 10, and this is division. So we are going to try to simplify this down, and so the first thing we have to do to simplify is to factor. And we factor both the top and the bottom. So we're going to do that first. So we're going to have x minus 5, this is a difference of squares, so x minus 5 and x plus 5. We know one term is negative and one's positive because we don't have a middle term. And then the bottom, we have x and x, and then to make 10 and to combine to get a negative 3, we have negative 5 and a positive 2. Okay, so that's our first step. Our second step is we cancel out, or basically reduce to 1, like factors from the top and bottom. So I'll say cancel out. We know that's not mathematically the correct thing to say, but that's what we say in here a lot. Cancel out, reduce to 1, like factors. And we do it top and bottom. All right, so here we have an x minus 5, and here we have an x minus 5. So what we have left is x plus 5 on top and x plus 2 on the bottom, and then we will reduce any coefficients if we have any. And this one we don't. So our answer in simplest form is x plus 5 over x plus 2. And now we've simplified. So if we look at our second example, example B, first we're going to factor, and factor in any way you want, guess and check, or by grouping, depending on what it is. Remember your special things. This here is a perfect cube. Perfect cube, perfect cube is a difference of perfect cubes. So remember how to do that process. All right. So we factor, and now we're going to reduce or cancel out like factors on the top and bottom. So we have 2x minus 3 and 2x minus 3. So what we have left is the 5x plus 7 all over 4x squared plus 6x plus 9. All right, you try the next one. We'll call that C. All right, we see our final answer here. Remember, GCFs need to come out first. Always look for those. First, A and B didn't have them. C does have them, so you need to make sure that you're factoring fully and taking those out. All right, now we're going to look at multiplying. So we're multiplying some rational numbers here, and we've got to think about the steps. Our steps are still going to be to factor first, and GCF goes along with that, so we always look for that. We're going to factor all pieces first. So we look at the first one and we say, okay, well, 7m can't be any more, so we'll keep it 7m. There is a GCF here, so we can take that out. We've got m plus 7. And then we do the other side. So GCF here, take out a 3. We've got m plus 7 over 9m. Okay, our second step, we're going to multiply across and cancel like factors. So we're doing that across from each other, not on top of each other. And then the last thing we're going to do is reduce coefficients. All right, so let's try our first one. So the first thing we look at is we say, okay, here we have an m plus 7, and across from it we have an m plus 7. Those can go away. We have a 7m and a 9m. We can cancel out the m's, okay? And then, so what we have left is 7 times 3 on top and 2 times 9 on the bottom, which gives us 21/18, but that reduces down to 7/6. Now, you could also do some reducing here. You could have that, get rid of that, and that turns into a 3, and then that would have got you there much quicker than 21/18. But either way, you're still going to get 7/6. All right, that's example A. Again, for the second one, you're going to factor fully first, and then do cross reduce, and then reduce your coefficients. So 4x squared can't be taken any smaller, and x minus 2 can't be taken any smaller. And we're multiplying, and here we have a difference of perfect squares, so that's x minus 2 and x plus 2 all over 12. Now we can start reducing. So x minus 2 goes away with the x minus 2. The 4, because we can divide it by 4 and get 1, basically, and 4 into 12 gets us 3. So what we end up having left is x squared times x plus 2 all over 3. And that's our answer. Okay, I want you to try C and D for this section and see how you do. So with C, you have x times x minus 5 over 2 times x plus 4. And with D, all of the pieces cancel out. Do not say that that is 0. They all reduce down to 1. Remember, when we say cancel out, a lot of people think 0, and that's why we don't like to use that word, but we're reducing down to 1. So when they all cancel out, they are reducing to 1. So it's 1 over 1, which equals just 1. All right, the next section we're going to talk about dividing. So here are some dividing, and we remember some old adage of things about when we're dividing by fractions, we multiply by the reciprocal, so that's going to come into play here. So the first thing, just like all the other steps, we're going to factor all the pieces. So when we start at this first example, we'll call this example A for divide. We have x, this is a difference of squares, so x minus 3 and x plus 3. The bottom we have a GCF of x, so we take it out, and then we have x plus 1. And we're dividing by x minus 3 on the top, and then this is a difference of squares, so that's x minus 1 and x plus 1. So that's our first step to factor. Our second step is we multiply by the reciprocal. All right, so we're going to reset this up, and we're saying x minus 3, x plus 3, all over x times x plus 1, and we change our sign to multiply, and we flip what was the denominator now becomes the numerator, and vice versa. And now we cancel out like factors, or cross reduce. And then just like before, we'll reduce coefficients if we have them. So we start here, we have an x plus 1 and an x plus 1, an x minus 3 and an x minus 3. So what we have left is x plus 3 times x minus 1 all over x. And we are simplified. All right. Here's B and C for this section, and you're going to have D. So I'm going to work B, and then I'll show you the answers for C and D and see how you do. On this one, I went ahead and factored, and this is written with a big division bar here between the two instead of the little lines. So I just wrote it, factored with that. Now I know my next step is going to be to multiply by the reciprocal. So this front part stays the same. I multiply and they switch spots. So multiply by the reciprocal. And then I'm going to cross reduce. Now, when I have here 3x times 4, that gives me 12x all over x plus 3. And this is my final answer in simplest form. All right, for C and D for this section, you can see the answers here. If you didn't get them right, go back and look and see what you did. It's usually a factoring issue, but remember GCFs and make sure you factor correctly. Now we're going to move to the section of adding and subtracting. And sometimes these can be a little bit tougher, believe it or not, because we know when we add and subtract fractions, we have to have like denominators. And sometimes they're not always alike. Now, these are not too difficult. We'll get into harder ones as we progress. But we want to start first by looking at factoring the denominator. So when we look at this example, and we'll call this example A for this section, B, C, and then this will be D, E, and F. All right, so when we look at A, we factor the denominator. Well, it's already factored for us, so it can stay 8A. Now, when we know when they're the same and we're subtracting, it's just 5 minus 2, so we get 3 over 8A. All right, so with our second one, B, we may have to factor the denominator on this one. So we look at this one, this is difference of squares. So this is y minus 3 and y plus 3. On both. So we know they're alike. So when we're adding, we keep the denominator, y minus 3, y plus 3, and we add the top pieces. So that is y plus 5. Now, if that case, once we add and subtract, then if we had to reduce, we would. Sometimes we have to refactor. So we first factor the denominator. We create a common denominator. Then we'll add and subtract whatever is needed, the numerators. Sometimes we have to refactor if possible or needed. And then, of course, we always reduce our coefficients. Now, I call common denominator CD, so if you ever see that, it's just a quick way to say common denominator instead of writing it all. So if we look at example C, we have 4x plus 12 and x plus 3. Obviously, they're not the same. So we're going to go ahead and factor those. So 4 can come out, and we have x plus 3 on that piece, and plus 7 over x plus 3. So common denominator has to be what all pieces have. Well, this piece has a 4. This one doesn't, but we have to have a 4. So 4 has to be part of it. Both pieces have x plus 3, so x plus 3 will be our denominator. So 4 times x plus 3 is our whole denominator. So when we keep it that way, 4x plus 3, this piece, this first fraction has that already. So it's saying this can go into this one time, and 1 times the top is 2. This bottom one doesn't have it. We have to make it have it. So we say, well, what did we do to get there? Well, we had x plus 3, but we didn't have the 4. So the 4 has to multiply times 7 to get 28. So then what we have is 2 over 4x plus 3 plus 28 over 4 times x plus 3. We go ahead and add. So we get 30 over 4x plus 3. We don't need to refactor, but we do need to reduce coefficients. How many times can 4 go into 30? And if it can't go in evenly, think about other factors. Well, 2 can go into both of those. So we end up getting 15 over 2 times x plus 3. And this is our answer. So we've got to be careful when we get common denominators that all pieces have taken care, and you've seen that before. All right, you try D, E, and F. I will put the answers here, and then we'll see how you did. All right, here are your answers for D, E, and F. Notice with F, I had to refactor. And also with F, you can rewrite. A lot of times people have problems with this right here. You can rewrite that as the same as y2 minus 4. because you can take it out with a 1, meaning this. I could say negative y squared plus 4, but then I can factor out a negative 1, and it's y squared minus 4. So I can get them to look the same. So if it's helpful to do that, you can definitely do that. So see how you did? And when you feel pretty good about it, it's time to move on to putting it all together.